Hi, everyone. Welcome to the Design Code series, a podcast where we chat about how AI, data, and design are shaping our world. Think of this as a space to explore how these technologies influences our surroundings, from homes to cities. I'm your host, Sarah Kademi, an AI scientist and fellow architecture enthusiast. Welcome to another episode of the Design Code. This one is called the Practice Code because we are going to talk about how things are getting implemented and how are things in practice. What happens when design and technology meets real world constraint. And I'm very happy to be joined by Laurens Tait from Arup. Arup is a consultancy company working at the intersection of sustainability, technology, and design, and they have been shaping cities for decades around the world. Cities are constantly updating and continuously rewritten by movement, by people who are traveling, commuting, and living at different places at once. Mobility is not just from getting from A to B, but it becomes one of the most complicated data systems that we have. Things are happening and decisions are being made at the same time. Very dynamic, very complex, and very important to understand. The overarching question for today is what happens when we start designing cities, not only from the prior knowledge, but from the dynamic data systems that we have from mobility and transport and using powerful technologies like AI. Laurens, welcome.
Thanks, Aaron. Thanks for having me.
Great. I would start simple. So, how would you describe your role today at Arup at the intersection of technology, AI, data, and what kind of projects do you work with when you actively working with data and AI?
Yeah, I mean, well, first of all, before starting, it's good to say that I'm a transportation lover. So I absolutely really enjoy and have enjoyed my whole career working on transportation projects. Within Arup, I'm a director. I am based in Amsterdam, and I am responsible for a team, a cities design and planning team, which includes transport planning professionals, architects, designers, and we work for our clients here in the Netherlands. We work also as part of a network, and but with a specific focus on the Netherlands, in particular, part of the market related to Dutch traffic agencies, transportation agencies that are building and realizing projects. We also work for municipalities. Cities bring along that integrated aspect of transportation with the built environment, and we also work for providers of transportation services. So think of an NS, for example. And so Arup is an engineering, design, and consulting firm based all around the world. But we have a very close connection with the colleagues that are implementing those projects in their different countries. So we worked as a network of professionals, and as a practicing engineer and transportation professional, it's a great pleasure to work with all the colleagues around the world. In terms of projects, so your specific question was around projects. I think it's important to say that transportation has many touch points with us and along the life cycle. So really from the early stage design and planning, starting with concepts through to realization, construction, and then not unimportant, the operational phase, making sure that things are realized and working effectively. We have touch points on all those aspects. Example projects in Amsterdam, we're developing new transportation plans for Havenstad, the new development to the north of Amsterdam for 60,000 homes to be realized in the Havengebied of Amsterdam, the Haven area of Amsterdam. We're also working on other station projects in Den Bosch, amongst others, and Dordrecht. And that's really the early stage planning phase when you're really looking at the data in a certain way. In the realization phase, we're working on, I'm working also on projects in Amsterdam Zuid, the realization of what we call Zuidersdok, which is the whole integrated station, tram, bus facilities for the business district of Amsterdam. project we've been working on for many years, and we're in the realization phase and constructing that now. In the operation phase, we also work with providers of services to users, for example, the NS, on analyses that support their decision making and their operational decisions. So that's really just a selection of small projects that I'm involved in, my team is involved in, and we're involved in, specifically in the Netherlands. I think it's safe to say that data plays a role in all of those in a different way. And we can touch on that later, but it's really integral in the way that we work. Really, it's really it's a very important part of our decision making and design process.
I would like to ask you about really the workflows. I think, can you tell us how does it look like? I mean, in which part of really these cascaded, let's say, design projects, you work with data in what stages and what kind of data? Really take us to one of your projects. Maybe you could talk about the 60K homes in Amsterdam.
Sure.
Yeah,
Sure.
because
Yeah.
I think this is also on spot, housing crisis in the Netherlands. And I think, well, what we want to know is that whether data and AI can play a role to make our lives better.
Yeah, I mean, yes, that's a great question. I think really the early stage design work that we're doing, and certainly in these kind of what we call in the Netherlands mirrored projects, where you're really looking at a large selection of design alternatives, their data plays an important role in. So specifically on that project or similar projects like that, then our workflow is really very specific to the question that we have. So in this particular question, there is a very clear brief from our client, which is all around how do we realize the necessary transportation services to provide connection in a comfortable and safe way to this new population coming to Amsterdam. How do we do that without adding more stress to existing nodes, existing stations and areas and existing services? And how can we phase that over the time and realize it in a cost-efficient way? Because obviously means are not unlimited. So really, with that in mind, what we do is usually have, generally for our projects, we start with a data plan. So our workflows are driven by a number of tools which depend on certain data items which we add into that. So we would generally have what we call an inception meeting to bring together the flow of work that's needed to answer the specific question and the data that we have that we can provide to fill and fuel that workflow. So that what we would call a data plan inception meeting would be the kind of discussion where you would look at the available data that our clients would have, and that would range from provisions from a rail authority, for example, a ProRail that has very specific information, spatial information, but also information about passengers, usage of infrastructure in the time. Other operators like the GVB, who run tram and bus services, have specific information around the kind of levels of intensity that their services are run. And we bring that all together in what we would call a model, a simulation. And those simulations are what we then use to then inform our decision making. And we could talk about what those tools are shortly, but really at the starting point, you want to really validate and discuss what you have as a starting scenario based on data which is provided by your transport operators, amongst others, or the city, or things like that. So you're really at the early stages, thinking about the question, thinking about what you need to build your simulations, and bringing together data to inform a starting point.
And do you usually get data from, let's say, this institute? How easy is to get those data? And my question is, are there any scenarios that you can actually, or you should actually collect and curate your own data? And how are your processes basically to take care of that data, mean, we are dealing with different kind of data, private. I don't know how much of the private maybe data are needed in your cases, for example, for the homes, for the transportation. And tell us a bit about really I would say, the nitty gritty of the
The
data
nitty
that you,
gritty. Yes,
yes,
exactly.
yeah.
Yes, well, I mean, the nitty gritty of the data is very variable. You know, it changes per location, per also per time. So there are aspects of granularity, for example, that are available or may not be available in certain locations. And the better the granularity, the more sophisticated the kind of simulation that you can do, and the more sophisticated you can take your simulations. Having said that, your question was around also whether we collect our own data.
Yeah.
And yes, we do. So particularly for large infrastructure projects where you are needing to have a starting point from a spatial or a qualitative perspective, large infrastructural aspects like bridges or tunnels need a lot of collection of data, which we would scope out, specify, and collect. And there we are using increasing means of computer vision to support the collection of that data. And that a specific example would be the creation of new or changes within existing tunnel or bridge infrastructure, where you have to survey that situation, bring it back together to the designers and the engineers to then develop a future situation. And in a tunnel, for example, you don't really want people working down there. It's not safe. So sending, for example, cameras, computer vision is
Sensors.
is what we've done. Sensors, which is what we would have done on projects like High Speed 1 or large tunneling projects where huge amounts of surveying data is needed. So the more we can automate that, the more we can use tools to collect that, the less people are involved in sometimes dangerous surveying situations. So it's also a good way to make a safer project, actually. So that's one specific example, and that's related to infrastructure. So the state of our infrastructure, which is in a country like the Netherlands, crucial. We're not it's not a greenfield site. There's things working, things that have existed for decades, for hundreds of years. So we're working in an existing situation. So collecting data about our surrounding environment is important. Collecting information about behavior is more sophisticated, has a different approach. So there again, if our question needs the collection of understanding of how people move from A to B in specific environments, then we would ideally work with our clients to understand if they have that kind of data already. You may be familiar with sensors around around stations that collect the way that people flow. So we would work with our clients on that data, because that's personal data. That's very private data, and we would never collect that ourselves without engaging with our clients. It's an important part of our work to make sure that everything we collect is secure, it's private, and we design that into our workflows.
And you have your own data, let's say, experts and data group that advise you on these things, of course. I think this is maybe interesting also for students or people who want to enter the job market a bit, to understand what kind of data skills
Yes.
You want at Arup.
Yes. So, and in particular, indeed, thinking about graduates and people coming into the work market, which I think is a very exciting time when you're a student, to think about, okay, well, what would my role be in the professional world? I do a sort of a lecture on complex buildings in the architecture faculty, and we have a similar conversation. And each year, also, the question changes, the answer changes slightly, but the themes remain the same. And I think for me, the most important is really the understanding developing values and developing a real core vision on what you want to do and to have a positive impact. I think that's number one. You want to do things that are good. Next to that, really understanding your trade and understanding how your trade fits within the broad spectrum of services and disciplines that are out there is this, I would say, the second thing. So if you're an architect, if you're a planner, if you're an engineer, you should know roughly where you sit within the whole ecosystem of other trades and other people that are working in this domain. And then to add should we say, the data layer, really it's about a curiosity. We look for people that are that have an interest to develop their digital skills with us. They have a basic understanding. That changes actually every year. So if you'd asked me this question last year, I would have said, you should be really hot on Python. You should be able to script very well in Python. I mean, now with tools like Victor, you can actually develop your own tools yourself using developers. So your actual personal skills are maybe slightly less important than they used to be. But you should be able to ask an existing software to be able to develop scripts for you. I mean, that's where we are at the moment. So really being intelligent, curious, and able to experiment with things is really what we're looking for. You don't need to know everything, but a curiosity and a basic understanding and intelligence around this domain is what you need. But most importantly, with a good vision of what you want to do and an understanding of how your profession sits in that vision, really. The rest, we can also help on that.
Yeah, very interesting, because now the curiosity is even more important than, let's say, the skills, the programming skills that you need. But you really need to have a vision about how things are working, and then as technology moves, because as you said, it's moving so fast. Every year is changing.
Sure.
And now you're almost prompting Python, and then LLMs are generating code for you. And more important is how to frame what you want.
Yeah.
And really to program it itself, because that part is already automated, which
Exactly.
is quite interesting. And I'm also curious about, because you brought up computer vision, and this is what I'm very interested in. So could you tell us a bit about what kind of computer vision models, algorithms, or frameworks are you using now at Arup?
Well, yeah. So on computer vision, so just thinking about the life cycle of transportation projects that I'm involved in. I mean, there are many use cases that computer vision plays a role in. So I mentioned one of them really in the collection of data perspective. So the tunneling example for infrastructural. Also, computer vision is used by our clients to understand how flows happen through their infrastructure. So that's also a little bit about. And there we're talking about stereoscopic vision and the kind of things that and the kind of tools that you would see, for example, in Delft with the team of Serge Hogedoorn, for example, looking at how people flow through spaces. So that is more on the collection side. On the construction side, we see computer vision, particularly with our contractors, playing a more important role in understanding whether sites and site safety is good. So being able to understand how, particularly when you've got a complicated building site where things are happening at the same time, then being able to flag unsafe situations is something which we're seeing much more now in the construction industry, where contractors like Heijmans, for example, are working with these kind of tools to develop a safer site. On the operations side, we see computer vision on the operating of, for example, highway infrastructure. So pricing is a theme of future road usage. So computer vision plays a role in that, in the collection of, what we would call ANPR, number plate recognition systems. And they actually are supporting themes to help users understand how much they've traveled along a highway infrastructure, and to then pay for that. And there where Arup is currently supporting the government in introducing a scheme here in the Netherlands. So we're rolling that out right now. And also on the operations side, computer vision plays an important role in autonomous vehicles, and being able to um, enable autonomous vehicles to operate in our built environment is something that we're keeping a constant eye on. In terms of the actual tools, we would, as a consultant, we would work typically with technology providers. So we would actually work with the best market players in these areas. We do develop our own tools as well. But I would say that that is more something that we do bespoke for specific situations. Otherwise, we would work with our providers of services
So
in
you
that.
outsource basically the knowledge
Yeah,
that you need
yeah,
on that
yeah,
topic.
yeah, and computer vision is also not just about the computer part; it's also about the vision. So the
Yeah.
lens itself, the
The
actual
equipment.
the hardware
Yeah.
is crucial, and that's something which obviously as some specific service providers have worked long and hard to develop an ability in this, and yeah, that's a very niche domain that we wouldn't enter in. So
It does make sense. Yes.
yeah, exactly. I mean, yeah, I'm not a lens expert, but it's a super important part of any kind of sensor, computer vision sensor strategy. Yeah, so that's but so we're seeing a lot of, and I think you guys are also involved in researching this field and working in this domain. We see huge opportunities for computer vision in the work that we do, but also the services that to transportation as well. Yeah.
Yeah, I think for computer vision, it's quite the beginning. I mean, it has been a long time for the research now, but now we see more and more the application and actually in real world and how things can be
Yeah.
actually developed when vision comes into place. When you compare it, for example, with text and LLM that they have advanced so far in the past few years, I think computer vision is still a baby. So
Yeah.
trying to
It's
learn how to walk, maybe. So I would describe it that way. Yeah, I think well, before computer vision, there were lots of also image processing that they're still being used.
yes.
And they're not per se AI, but well, they paved the way for AI and visual AI to become an assistant in, let's say, many ways, as you said. So autonomous driving is one of the most important applications. But what I want to know, because I know that, okay, there are lots of technical people trying to, let's say, collect data, to operate with computer vision, different technologies, basically to create insight, to create information, to create knowledge. But somehow the cities run not on insight, but on decisions. So, and you probably have many, well, clients from government and authorities, policymakers. So I would want to know how do you communicate basically these insights to the decision makers, and what's hard in this process?
Yes. So indeed. So as designers, as engineers, as consultants, our role is to create a basis for a decision. A design is actually the outcome of many little decisions, some big decisions, some little decisions, all the way along, and you come with a complete, what we call design, which is actually the collection of all those in one kind of proposal, your scheme, your project, your building. So essentially my role is to help my clients make those decisions and come to conclusions. And that could be a design or it could be something else. And I guess really, and so your question is about how do we work with tools and how do we work with, specifically with improved tools and AI in particular, and with our clients. It's
But also how you explain it, because
yeah,
I think there's a gap between, okay, what the algorithm spits out and how you understand it as a, let's say, expert, an AI expert, and as a designer, then you're a great explainer. So you need to
yeah.
explain all these decisions to your client, and I'm interested in the explaining process.
Yes. Yeah. And this is so we're seeing this. Well, to be honest, we see this all the time. I mean, we as designers have always dealt with complicated information and brought it together and tried to tell the story. That's essentially our role. And the tools are sophisticated, and they're becoming more and more sophisticated and more fast and more specific. So, two examples. So, well, we work with simulations, particularly in the transportation sector. We work in simulations which actually give us an insight into a future scenario and how a system will operate in that future scenario. So at the moment, we're working with models and simulations that you wouldn't really call them, well, at the moment, traditionally, you wouldn't call them AI tools because they're not learning. So they're basing their predictions on rules that we create. So those rules that we create, then they're not going back in and changing the simulation. So that's a traditional model. And what we on the traditional model see is faster simulation times. So tools that would typically take us 2 days, 3 days to run are now taking 2 minutes, 3 minutes to run. And in particular, we're working on models, for example, in the transportation model of the United Kingdom, and testing scenarios, and they're becoming much faster through the use of, amongst others, graphics cards that are helping us run simulations faster. So that's, and we're doing that also in the Netherlands with our technology partners for the province of Noord-Holland, for example, testing scenarios super fast. That means that you can actually test things with a local authority, with the government, with an interested stakeholder, pretty much live, and something that you would typically have taken you 2 or 3 days to organize and to present. Now, that's great news. The real challenge in that, and what we're finding actually, is that the human interaction still remains. So the simulations are going faster, but the human's still in the room. So we are testing scenarios live with stakeholders that really are trying to understand what's happening. So what we're seeing is that we're having to adjust our processes to be more a sort of a curator of the modeling and the outcomes, and that we actually are working very closely with communicating the outcomes of the model to our clients on the spot. So that's, should we say, the outcome of a challenge in relation to faster models. But if you're thinking about AI and should we say, the implication of learning in these models, it's really, we're still at the early days. So we are developing models where learning from previous runs of simulations is brought together as a basis for a model that can, summarize quickly what a potential outcome could be. The important thing there is that there is always a human involved. There's always a professional involved to give a professional verdict on what comes out, just to make sure that it's reliable, that it's valid. We only work with tools that we've really tested and risk assessed, or are available through licenses that we would pay for. And the data that we would use in there would remain within that environment, so it would not go anywhere else. So they're closed environments. But in those kind of situations, we are working with clients to understand how they can get the most benefits out of that. But the same rules apply. The human is still in the room to kind of give the voiceover of the outcome, because the decision isn't in the analysis. The decision is in what you choose to do as a client, as a professional, as a designer. That's today. I mean, that's 2026. I mean, we are obviously looking beyond today.
Yes.
So we are looking at ways that we can improve that client access to our analysis and tools so that they can themselves make decisions. And we're doing that, for example, on projects, a metro in Copenhagen that we're working on, where we give access to our data, and in a closed environment, our models, our reports, our projects, data, through a large language model that our client can personally interface with and access it to ask questions. That does two things. It's, it means that we only get the really interesting questions, actually. So all the relatively simple, straightforward stuff can be solved on its own, and only the interesting stuff comes our way. So it makes it a much more efficient process. It also gives access to our clients to, really the vast amount of other information that we generate in a project that they wouldn't typically get access to. And so it's also for them potentially a more rewarding experience. Plus, I think generally in society there is an expectation that you will get a specific type of service. You have an experience with your phone, which is an amazing experience. So you also expect it to have that experience with your designers, with your consultants, with your engineers. We're not there yet, so the phone is still doing really well, but we're doing our best. And at the moment, the human's still in the room, and it's all about just voiceover to the outcome.
Yeah, very interesting because what I hear from you uh, is the speed that actually is changing the game. So you mentioned, well, the computation because you can have real-time simulations and the client and different stakeholders can actually see what's happening on spot rather than really seeing the, let's say,
Correct.
the slides
Yeah.
made from the simulations. And the other thing is also, again, this kind of iteration, this mediation of LLMs, for example, that can play a role in make things more efficient and faster. And this is all about automation. It is what part of the workflow you are going to automate. And this is what you're using right now. And I would like to use your brain, your insights, that what do you think would be next in the future? Let's say, I don't know, in 2 years, 5 years, what do you expect? Or
6
what
months,
are
6 weeks.
6 months?
Yeah, exactly.
What are your wishes? Let's put it that way.
Oh, that's a big question. So first of all, what we're trying to create in Arup is a space where within the correct guardrails, professional work can be done and delivered according to the quality that that as a professional that you subscribe to. So that it's safe, that it's effective, that it's efficient, that it's that is physically works. That's number one. So the guardrails are in place, and they involve things like testing, risk assessment, reviews, parallel runs of different workflows just to test things while you would do it in a traditional way and to get the answer that you are comfortable with.
You mean different, for example, design scenarios?
No, not within design. So numbers of design scenarios. In any case, we would develop vast amounts of design scenarios. In fact, increasing amounts of design scenarios because of the speed of the computational power. I mean more parallel workflows. So you would follow a traditional route, and then at the same time see, okay, well, what if we tried it a different way, in a safe space, in a safe environment. Just to experiment and to be curious about the tools that are available. And so really creating that culture and the guardrails to be able to do that is what I'm excited about. What comes out of it, I don't know. I see a lot of exciting things that could lead to new avenues. I mean, obviously everybody is talking about agentic AI. So, I'm sitting here today talking to you as a professional engineer, but we're also experimenting with professional engineers that are not humans, that are actually agents, and what would be needed to put in place to be able to create that kind of professional that is able to do the basic tasks that an engineer does. So that is the direction that we're looking at.
And what are those basic tasks that an engineer
what an engineer does? Well, I mean,
does, and you would like to automate it?
Well, that's for sure. I mean, there's obviously a lot of things that we've automated already. If you look in Arup in the tools repository, we build vast amounts of tools just to do things better, higher quality, more effective. So that could be from basic structural design, analysis, cleaning up data, analyses of quick static analyses, dynamic studies. There are very many disciplines in engineering, so it depends on each discipline. What's central, though, is the kind of professional code that you have as a trained, designer, architect, engineer, from structures, MEP, whatever. You have a professional code, you have a professional integrity and somehow finding a way to understand how that can be, how you can work with that in a new form, I think is very exciting. So we're looking at that at the moment, and it essentially boils down to being able to do simple tasks that you would do as part of a design process at the moment. But I mean, it's still early days. So in the future, I mean, you might be here in 2 years' time, chatting to somebody else who's not actually human, talking about those projects. And no, I mean, that's quite far away at the moment, but certainly our clients expect to see somebody turn up for the project meetings and to defend the design when needed.
Yes.
And also, to be honest, and we see that also with analysis, not everything that is measurable is important, and not everything that is important is measurable. So there are a lot of gray areas that are still very hard to automate. And so our abilities as professionals to be able to make that judgment call in the
Yes.
gray areas where there isn't necessarily the data available are still very, very difficult to capture. I mean, and I'm talking about things that are maybe related to ethical questions or political questions or budgetary questions where there isn't a clear rule, and they're usually trade-offs that you make.
Constraints when it's
Constraints where several things go in different competing directions, and you really have to advise to go in a certain way given those constraints. And I think those are the areas that are probably the most demanding, I think, in should we say, if I think about the future and agentic AI, those gray areas that are very much associated to judgments. That's hard. But yeah.
You don't want to delegate those kind of decisions. Yeah, so what I hear now is that you really want an agent that can collect different kind of data and digest it into some kind of insights that can inform you, and then you can better do the decision making with more support, more evidences, let's
Correct.
say.
Yeah, for sure. That's a simple task that indeed would be a great one. In fact, I mean, if we survey our teams, then I would say we have surveyed our teams, and about 40% of people use some form of artificial intelligence every single day in our teams, and maybe another 30% use it in the 2 or 3 days, and that varies from large language models, obviously the products that we work with our suppliers, things like Copilot, that are embedded in our tools, but also things like analyses that we do, scripting that we get support on, all those, and it varies all the way along. So, but at the moment, it's precisely what you said, the decision, the judgment is still made by us, and it's made at the end by a professional who decides if it goes out of the door. So it's yeah.
Okay, so I would like to ask a different question, because looking at how architects work, because now I'm working at the Faculty of Architecture, they are looking for precedence. For example, when they're given a design brief and they need to design something, then they look for what is feasible, and what is feasible always translates to, okay, what has been built already, so we can learn from it. Precedence, and we see lots of, let's say, analytic AI trying to find relevant precedents for designers. Is this something that you work with at Arup, or traditionally, or I don't know, with technology? How is this in your workflow?
Yeah, so I think that so what you're saying is the assessment of either previously designed buildings, existing buildings, or existing infrastructure, and using that as a basis to inform future
and justify these design decisions.
No, so yes, we definitely do this, and this happens along multiple disciplines. and it comes together in in an integrated way. And so a very specific example would be a service that we offer, a product that we offer called Inform, which is actually the parametric, well, it's a parametric design aspect or approach, but it's informed by the analysis from a large body of evidence along multiple lines. So, for example, if you have um, a services question, and you need to know roughly the kind of dimensions of a specific service installation that you need, or a climate approach, then you could either go ahead and design one product very well and do it the traditional way, or you could assess a vast array of options of variants very quickly. So in that very early optioneering stage, you don't want to do a very deep analysis. You want to do a very broad, quick assessment. And that broad, quick assessment is done on the basis of existing and historic designs or collected evidence. It's also done along multiple routes. So, for example, you could introduce aspects of structural needs or flow benefits that you would have within a particular orientation or organization of a space. And that we would do, for example, on multiple runs of previous designs or other specific designs that would create a sort of a battery of data that can be pulled on to draw a parallel with a current situation. So that is a data population that we would create to help doing those quick fire assessments that you're talking about, where you would typically by hand collect a whole lot of examples and then by hand actually just assess which one is relevant for your current question. So that is for sure something that we do, and it's done across multiple disciplines, and it helps do the early stage collection of evidence. Where it's now going is really really leaning into the abilities of models to synthesize this data into a way that we could really use it in a more sophisticated way. So that data collection exercise has existed, but it's now the processing which is becoming more interesting, and the ability to bring that together and assess multiple options is really, really exciting for us, very interesting. And for a client, you'd really want to test every potential alternative before you make that decision. The selection of variants, is in this way increased dramatically. So you don't have to go for like the 3 or 4. You can actually assess hundreds. So that's where it's going. I think it's similar to the example you were giving, where you would collect a series of examples and prepare an analysis. Yeah.
But you would see it positively. For example, there's an agent that can do this analysis for you. So you can give it, let's say, a project description, a design brief, and it can search for relevant projects, I don't know, in Arup or across the world, so that you have a better starting point by studying those kind of projects, see what went well, what went wrong, and learning from those processes. And even better if the agent can learn from those, let's say, processes, and then generate something on that basis.
Yes. So that last step is not currently where we are.
No.
I mean, that's where it might go. Correct. But that indeed the ability to lean into a vast set of experience that we have, opens many opportunities. Certainly when applied to some of the tools that are available now. But it's a continuation of something which has been developing for many years. It's just an additional, should we say, aspect that we're weaving into the workflow. It's not revolutionizing the workflow. It's adding else, adding to it, making it more sophisticated, making it better, making it a deeper understanding, but adding to an existing trend that we see and that we've been working on for many years.
Okay, interesting. Because you say that, well, you've been doing it manually, so basically automating it wouldn't change it dramatically because it has been there. Let's say it doesn't change the workflow. What is so revolutionary? What would be something that you say, okay, this would be a science fiction of I don't know, engineering in Arup or like in general?
Yeah, I mean,
Just get
my work is,
imaginative.
In my work, it's really science fact. Science fiction is definitely in transportation. The number of times that we've seen people launch flying cars, for example. I mean, that's
Yeah. Yes, true.
certainly. I mean, that's been the future of transportation for a very, very long time. But no, on a serious note, I do think that, well, for a start, my vision is to provide transportation services in an equitable way that everybody's able to go from A to B, to do the things that they want to do in their life. So for me, that would be the ultimate vision, and it's not necessarily
To bring justice to transportation.
correct. That
Okay,
everybody
very
is
interesting.
able to carry out their working life, and transportation plays a big role in that. Technology could play a big role in that, but doesn't have to. But so that would be my ultimate vision. And is it science fiction? Yeah, I mean, it's still something that we have to work on.
Human fiction.
It's
A
human
bit.
fiction, yeah,
Yes.
exactly.
But where's the bottleneck for that? Because I think I wouldn't think of that question, but you mentioned it as such a, a long wish, I would say. So what's really difficult to bring transportation justice, mobility justice to everyone in a city and in an advanced country like the Netherlands?
There are no. I mean, obviously, in an advanced country like the Netherlands, the challenges are different, but there remain challenges. They are mostly to do, certainly in the Netherlands, with cost of living and the ability to provide an appropriate accessibility to a function that you want to have and an activity that you want to do. And there is still work to be done. An equitable transportation system is still something that we are working on. So in our projects, we are very keen not just to look at the averages of transportation users, but also to really, and this is where data plays a role, to really dive into the outliers, the things that are not necessarily average, but very, very important.
Marginalized communities.
And certain groups that might be affected by transportation decisions that will have a negative effect, and that is sometimes somehow lost in the data. And so really, what we try to do, and that's why it's very important to also have a professional in the room, a human in the room, I think, is to assess the outcomes from a qualitative perspective. And there we use things like user experiences, tools to really create kind of for ourselves an image of what we think an affected group from a transportation design could be, and just to really think about that. And that can sometimes be strangely overlooked, and even in a very advanced society, sometimes decisions are made which have a negative effect on people. So barrier forming is a very big part of infrastructure. So this highway here creates disadvantages for certain people to get from A to B. Price and costs are in particular of moving around are crucial. Options, that you have alternatives, that you can do different, you can take different choices. Also maybe biases that one would have towards certain parts of the population, and that you would not actually consider all the breadth of solutions of people using transport. So I would say that would be my human fiction. I like it. That where all these topics are covered and dealt with in a really optimal way, so that we find a solution for everybody. I think that's
Okay.
and the role of technology in that, it's not leading, it's helping.
Okay, very interesting. Do you have like the last words for our audience?
Oh, well, the last words for our audience. Well, I think, if there is any very talented and interested and curious graduates out there, for example,
yeah.
that are very keen to apply their design skills in, say, more of a technocratic environment, because obviously, the crossing of engineers with designers brings a certain kind of approach. So you have
Dynamic.
to be, yeah, exactly. So you have to really have an appetite for that. Really, we're very excited to work in the Netherlands, because there are some great academic institutions like Delft that are producing research, but also very talented new graduates that are entering the market full of great ideas. So I'm, always excited to hear stories from the professors, but also the students, and the things that they're looking to do, and those could be end of year researches, or end of study researches, or internships, or even applying to us to work. So that would be. Sorry, it's a little pitch there. We're looking.
No,
we're always
yeah.
looking for talented and new colleagues to join our teams. So that would.
That's great. And what I hear is that, multidisciplinary, interdisciplinary is the key, which I totally agree. So for the students, for the graduates who are curious about how technology can shape the way we live, I think then you suggest, Arup is a great place to be.
Yes, of course, and and it's a fun, dynamic environment, and with access to many different disciplines, but with shared values and a shared direction. I think that's the most important to say.
Great. Thanks a lot, Laurens. Great conversation to be continued. Thank you for watching or listening to this episode. If you have questions for my guests and me, please comment them down below. If you would like to learn more about me, Seyran, please contact me at s.academy@sciencetudelft.nl. If you would like to learn more about our sponsor, the TU Delft AI Initiative, please visit their website at ai.tudelft.nl.